Hi, my name is Asuka, and today I'm going to present on my Engineering Math 3 assignment on Euler's method. Euler's method is a numerical technique used to solve first-order ODE, and an exact solution is difficult to find. It works by estimating the curve one step at a time using the slope, aka gradient of the function. As you can see here, my black curve here is the solution, and my blue line is the slope. Using the blue slope tangent to the curve at a point to find the next point that is approximate to the black solution curve. So here we got a point x0 and y0 and x1 and y1. So the difference between x0 and x1 is h, which is the step size. And then my blue line, for example, is dy over dx equals to f bracket x comma y. And then from the right angle triangle, we can use the formula used to find the slope of rise over run. So fx bracket x0 comma y0 equals to rise over run. Then from there, we can find our rise, which is y1 minus y0 equals to h times f bracket x0 y0. And then we can just get y1 equals to y0 plus h times f bracket x0 y0. The same goes for y2. Then x1 is just x0 plus h, x2 is x1 plus h. Then I can derive the Euler's formula yn plus 1 equals to yn plus hf bracket xn yn. Let's move on to the Excel sheet. As you can see here, this is the question given to us. For dy over dx equals to x squared plus 1 over y, where y is more than 0, given the initial value y bracket 0 equals to 1, find the approximate value of y bracket 1. So as given the initial values x equals to 0 and y equals to 1, I've put it here. So for the next value of x, I add 0.2 to it as I'm using a step size of 0.2. Then I just drag it down so it adds 0.2 to everything. Then my y value is, my previous y value is b2 plus step size times c2, which is the differentiation. Then my third column is just dy over dx, which is gotten from the question given. So it's just a3 squared, which is x squared plus 1 divided by b3, which is y. Then we just drag it down, we get the rest until x equals to 1 as they have asked us. The next one, I've used step size 0.1 to compare both. So here is just the previous x value plus 0.1. The same goes for y. It's just previous y value plus 0.1 times the differentiation. The differentiation stays the same. It's just x squared plus 1 divided by y. Let's move on to my general solution. So for the general solution, I found dy over dx equals to x squared plus 1 over y. So I found out is y equals to plus square root 11 over 3. I eliminate negative because they say y is more than 0. So square root 11 over 3, I put it as 1.9149 made to 4 dp. Then my Euler solution I found here is 1.9095. So next we are finding the approximation error, which is the general solution minus your Euler solution. So approximation error for the step size 0.2 is 0.0054. Let's move on to the approximation error of a step size for 0.1. So here, we use the same formula, general solution minus the Euler solution, and it is 0.0035. As you compare both, the approximation error for the step size of 0.1 is better. So I can conclude that the lower the step size, the better it is because the approximation error is lower. So we get the more approximate answer. So we can use a lower step size. Thank you for listening to my math presentation.